Hi, everyone. Is this thing on? Yep. Cool. So I'm Ross Dickey. I work at Rapid7, and today I'm going to be talking about password entropy. So, come on. Click, damn you. There we go. So obligatory about me, I've worked at places, started out as a sysadmin, software developer, QA, support, back to development, and DevOps, DegSec, whatever other words you want to slice in there. Currently work at Rapid7. So why do I password? Well, at a previous security company, we were working on a research project where we man-in-the-middled a smart TV for its communications back to their servers, and we found this config file that was obviously signed by like an MD5 or something, so we wanted to crack that. Tried to, didn't, found it in the code anyway, so it was fine. But that was concurrent with the Ashley Madison hack, so I had this perfectly good password cracking server and a bunch of perfectly good, bcrypt hashes that I could throw a bunch of word lists at and play around with password hacking, so or cracking. So that was fun, and it got me interested in like what makes a password good, because obviously the ones that I was cracking were not. So that led me to password entropy. So entropy is disorder, randomness, unpredictability in many different contexts, including particle physics, as you see. Entropy is chaotic neutral. It's neither good nor bad. And it's measured in terms of passwords in bits. So a bit of entropy is a coin flip. So the more coins you flip, the more bits of entropy, and it's exponential. So if you have 2 coins, there's 4 combinations, 38 coin or 28 coins. 38 coins is 270 million. So that's how that works. So if you know the number of possible combinations that you can get from those coin flips, how do you figure out the number of coins? If you remember from high school math, you have a thing called a log roll. So you do the base 2 log of the n, which is the number of possible combinations. So as an example, password, there's 8 characters, 26 lowercase, 26 to the 8th is 200 million or whatever billion, and that gives us 37 bits of entropy. So another example, ssw0rd, or ssw0rd, or however you say it, 96 possible characters in that whole range of classes. 96 to the 8th is whatever that number is, and so you've got 52 bits of entropy. So that's cool, but what does this actually mean? Well, the question is how fast can you flip these coins, and that's dependent on the hashing function. A hashing function is you take the password, put it through the function, and then you get this garbage. And you always get the same garbage when you put the password through that same hash. So the garbage is what's stored in the database, and you can never get the password back from the garbage. So as an example, if you take password, number each letter in the alphabet, add up those numbers, you get 115, and that's what your garbage would be. So that's a pretty weak hashing algorithm. So is NTLM, but that's what Windows uses, and it's used all over the place in enterprise. And but the reason it's weak is because it cracks very quickly. And of course, Microsoft said, this sucks. Let's use it for 20 years and not change it. But why is it weak? So there's this cool piece of hardware you can go online and buy for 20 grand. Now, not every password cracker's mom has this in her basement, but it is a good sort of yardstick for how quickly passwords can get cracked. So NTLM hashes, it can do about 500 billion, is that the number? Per second. So here's some pretty graphs to graph a logarithm. So the log scales on the left, the regular scales on the right. 1,000 days is about 3 years, so you can kind of see 3 years, 30, 3,000, so on and so forth. But so given the number of bits of entropy, that's how long it would take this particular piece of hardware to crack it. I chose this piece of hardware and not a regular laptop or CPU or whatever, because that's not what professional password crackers actually use. even though it's what every freaking password strength meter on the internet uses, which is just dumb. But anyway, so password secure, right? No, because you don't actually try every possible combination of those characters, right? You pull a password from a list, try that, change it slightly, and then try that, and then change it slightly and try that. So that's how real password cracking is. So it's great to guess passwords faster, but you have to guess them smarter as well. So if you think about entropy as the number of possible combinations, if your password is actually in one of these password lists, then that's the corresponding bits of entropy and the amount of time it would take to crack that password if it's in TLM, with that piece of hardware. So the ROCU list is a very commonly used password list because it was leaked plain text to the internet. So what if I leet speak a password? Well, that does help, but it only adds a couple of bits of entropy, right? So if you take even like a long word like ambidextrousness, sounds like it would be a good password because it's so long, but since it's in the English dictionary and it's simple, predictable transformations, it's really not that much better. Random capitalization, it's usually not random. It's usually the first character of the password is capitalized, and they say, yay, now I'm password compliant. So doesn't help much. So punctuation and numbers, people, if they're not leet speaking, they're just adding it to the end, and like that only adds a couple of bits of entropy at most, and especially because it's usually like a birthday or 1, 2, 3, 4 or something dumb like that. So what about random words? Well, this can be secure if the words are actually random. Everyone knows the correct horse battery staple. I don't have to put the whole comic here. So Randall Munro, the guy who drew it, claims that this is a 44-bit password. And he got that number by basically saying these are 4 of the 2,000 most commonly used English words or something like that. And so that's not too bad. But 44 bits, if you recall, can still be cracked fairly quickly. But it needs to be random and not something like Shakespeare, because that's not random. You can make a password dictionary of all the Shakespeare quotes, but even better is you can just take the top 50 or 100 that is everyone's favorite, and that's a very low entropy password. So I hate rotating passwords. Doesn't everyone? It encourages very low entropy passwords like these, right? I mean, spring 2017, bang. Oh, you use that. That is your password up here? No? Okay. Right. So I did give this a version of this talk to a friend who works in the healthcare industry, and she said, oh, that's actually a really good idea. People forget their passwords all the time. I just need to tell them to use this on their HIPAA-compliant devices. No, that was not my point. You missed it. Anyway, so yeah, rotating passwords doesn't help. Maybe adds a couple bits of entropy because rather than company name 1, I have to try company name 4. Doesn't help. So can we still use entropy if the measurement sucks so bad? Well, gave this talk at AHA in Austin, which is the Austin Hackers Alliance. The guy who started the company that makes the Brutalis, that password cracking system, came up to me afterward and said, hey, great talk, except that we don't use entropy anymore. Like, okay, so what do you use? Well, we've been working with Microsoft to figure out a new way of calculating how good, making a programmatic password strength meter. And I said, oh, that's really cool. What have you come up with? Oh, nothing. Everything that they've tried didn't work. Like they could find a password that was a terrible password that the strength meter said was awesome. And so I think the issue is that sort of the old way of thinking of entropy is that you just look at the character classes and like that's your entropy, right? And we're trying to get a better definition of it. And so mine is more of assuming all possible knowledge of how the password was created. How difficult is it to guess? So if I know that a password is, or I can assume that a password is like 20 characters randomly generated, then sure, I can use that old entropy calculation. But if I know that people commonly use like their name, their company name, their birthday, that sort of thing in their passwords, then that shrinks the possibilities of what their password could be considerably. So, and that's the problem with making a programmatic password strength meter, is that the computer needs to have all of this knowledge of how you generated the password and think like a human. And so that's why I think that it'll be very difficult, if not impossible, to create a password strength meter programmatically. So moving on from that, how long should my password be? I was told that length is more important than complexity, which is not completely false, but it is misleading, right? I mean, having a longer password, misleading. Sorry, I mispronounced that. So length is an emergent property of entropy. So it is not an indicator of how good a password is. So, there's some good passwords here, and these were all randomly generated. But if you notice, the shortest ones have the highest entropy. So, and the longest one has the lowest one. And I threw in a pronounceable password, I bet a ssw0rd, which I memorized for this talk just to show that it was possible to memorize randomly generated passwords. But I mean, those are fairly short and pretty good. So bad passwords can be really long. Like this is actually a misspelled supercalifragilisticexpialidocious, but it's in the ROCU list exactly like that. There were 10 different misspellings of supercalifragilisticexpialidocious, but no correct spellings of it. So I had to, in the ROCU list, so I had to pick one of the incorrect ones. And it's crap, because it's in the list. And a lot of people like picking Bible verses or whatever, so I found the longest Bible verse is ssw0rd or something. It's 447 characters, which sounds like it would be like a 2,400 bits of entropy password, but it's really no better than the shortest Bible verse, which is Jesus wept, right? That's it. I happen to know that for reasons, but so 447 characters, 9 characters, same entropy. Length does not always help you. And just for fun, I threw supercali whatever into 2 different password strength meters, and they told me, like, it'll take 10 whatever the fuck that number is, years. And no, it'll take milliseconds, microseconds even. Everyone got your pictures of that? Yeah, cool. So long passwords won't save you. So a pen tester actually told me, hey, make sure you make the point that length is more important than complexity. For example, I use SAT questions as my passwords. And I thought, oh, that's great. You use the SAT words to generate your word list for diceware. No, actual SAT questions. So word to the wise, go find a dump of SAT questions, put that in your password database, and use those as well. But his point with that was Hashcat can only crack passwords of up to 27 characters, and it's actually either 27 or 16 or 8 or 52 or 55, depending on the hashing algorithm used. But Hashcat's not the only tool, right? I wrote a Ruby script and ran it on this laptop, and I got 700,000 MD5 hashes per second on this laptop. So you don't have to rely. You can't say, this particular tool can't crack my password. You have to think, can a person think of a way to crack my password? So, and along with SAT questions, obviously song lyrics, literature, that sort of thing. So, little story about Alice and Bob. So Alice is our security person. Bob is not an idiot, right? He's computer science guy, engineer, scientist, lawyer, teacher, something. And he's smart, but his skills and Alice's skills don't completely overlap, right? There's some overlap, but he's not a dumb guy. So if you take nothing else away from this talk, remember that your users are not idiots. They just don't have the knowledge that you do. So Alice tells Bob, contrast that with Don. Every organization has a Don. There's Dons from the peon to the presidential level that are just idiots. There's no getting through to them. Anyway, assume that you're working with Bob's. So Alice said, okay, generate a password, or come up with a good, secure password, and I'll try to guess it. And she does on the first try. So, of course, because Bob is going to pick something like his pet's name, or his wife's name, or his kid's name, right? On the assumption that this is personal information, like it's a thing that I know, but no one else does, and that's not true, right? First of all, if your password hash is leaked from a database dump, there's going to be username, your address, your social or email address, or other personalized information, and even if they don't have that, they can guess it, right? And you also don't just want to protect your data from people you don't know, like random password crackers. You want to protect it from your friends too, right? Fun story about that I don't have time for. So these are all bad passwords for obvious reasons. I'm 6'5", big dude. Last name is Dickey. High school nickname, Big Dickey. Probably not the best password for me to use. My birthday is also January 23rd, so adding 1, 2, 3 at the end, not the best. Same problem if you're June 9th, 1969, or April 20th. Like these are personal information, but it's still things that people are going to commonly use for other reasons. So you can debate whether or not these are good usernames. But so what do you do? Obviously, password managers are great. I use them for every password that I don't have to memorize. But for the ones that you do have to memorize, I still use a password manager, just use it to generate passwords that I can actually remember, like our friend ssw0rd. And if you need the password complexity compliance, just capitalize the I and throw a bang at the end and golden. It's already random, right? So just adding a little dumb crap at the end doesn't matter. So there's also diceware, which I mentioned earlier. I lifted a diceware generator, Ruby, because that's what I have been programming with. But I added the password complexity requirements in there, so you can tell it insert random digits or capitalized characters randomly and that sort of thing. So I mean that's kind of nice because it's fewer words that you have to memorize. You just have to remember, oh, where was that caret? Was it between this word or that word? So anyway, feel free to fork that and make fun of me and that sort of thing. So of course, don't forget about MFA, because even the best password is useless if it's leaked in plain text. And the whole point of MFA is if one of your factors it falls over, at least the other one's still standing there pouring milk down its pants. So there was a good password list talk last night. I'm sure it was good. I didn't attend, but I'm going to assume it's good. I don't think password list is really going to be a thing near term, because you want to have multiple factors for authentication when you can, right? There's something you know, something you have, and something you are, right? So the something you know is a password. Password by any other name, still a password. You can change that. You can learn new things, right? You can buy a new YubiKey or a new phone or whatever as your second factor. But for biometrics, you can't change what you are, right? You've got one thumbprint, and if that leaks, you can rotate it 9 times, but then that's it. You can't rotate these things indefinitely, barring surgery, right? So I think it for the time being will be a good idea to keep the thing that you know factor, so that we're not reduced to have and are, because obviously are, you can't rotate enough. So how do you measure password entropy? Well, it's hard for me to measure your password unless I crack it, right? So you can think, okay, how did I come up with this? What information did I use? Is it personal? Is it random? Is it not? Some combination of those things. So you basically have to figure out, like, this piece of the password is randomized, this piece is not, this piece is not, this is, some transform of my name or a thing that I know or a lyric, and you have to really think through, like, if I wasn't me, but I knew me as well as I knew, could I have come up with this password? So anyway, yeah, that's it. Thank you. And that password down there, I actually, I didn't generate that exactly. I just wanted the mnemonic of Troll Start Lag, Leroy Jenkins, for those of you who catch the reference. Anyway, questions?
Come on.
Come on, this is a very contentious topic. Oh. There we go, there's one.
This is a great talk. The issue is it's a 25-minute talk. Mm-hmm. If you reduce this down to a soundbite, a snippet, a thing you can show the user before they pick their password, what would that be? What would your one piece of advice be for that user?
I would show them how to generate random pronounceable passwords with something like LastPass or what have you. Doing the exercise of pick a password and I'll try to guess it like that. That's cool if you can make that work, but it's not, you're not always going to be able to guess it on the first 10 tries or whatever. But yeah, that's what I'd say. Or diceware if you like having lots of words. There's, I think green shirt was first.
So I was at the talk last night that you were saying was good and that you did not attend. One of the big things that he was saying moving forward with passwordless authentication was the use of magic links. He talked a lot about how Slack was doing that, and I'm curious about your perspective on magic links. I know that doesn't directly relate to password entropy, but
so you mean magic links as in like they send you a link via email?
Yeah.
So you still have to have the password for the email that you know? Right.
Sorry, could you say that one more time?
So you get a magic link in your email, but you have to log into your email somehow,
right?
To get that magic link,
correct? Using
a password, right?
Yes.
Or do you get like an SMS with a magic link to log into your email, and then you're like at some point you have to have something that you know to authenticate you to a thing, like or some other factor, right? I mean, yes, that can be nice, but yeah,
okay.
If you're getting an email, you still have to log into your email somehow, right?
Sure. Yeah. Okay. Just curious.
Call it a fourth factor.
What about the idea of using large blacklists to prevent users from entering bad passwords? So say like I've had the idea of you take, I don't know, the 1,000 most common passwords, you use John the Ripper to get the 1,000 most common variations of those passwords, store them in like some sort of mapping or even a Bloom filter, and then just if they try to enter something that's in that, just tell them no and pick something else.
Yeah, so I think Twitter does that with the 500 worst. I would like for them to see. I would like to see them do it with a much bigger list. I actually had the idea of like creating a web service that had millions or billions of passwords that you could check against, or like some kind of product or whatever. Never materialized. Brutalis guy had the same thought. So I think that would help. Basically show that this password is vulnerable to a dictionary attack. There's some funness around securing that, and do you check the password plain text? Do you try to like transform it before you check it? So yes, I do think that would help, and I wish that more services would actually do that. But I mean, it's an extra step that you personally can't take, but like a web app or something could and should.
So how would you calculate entropy on like a diceware list? If you had, say, a 3,000 word list that diceware uses or something.
So the diceware list uses 7,776 words because that's 6 to the 5th. So take 5 die and roll them. So that's really easy. Now you know that there's there's that number of words. So the base 2 log of that is 13.7. So for each additional word that you add, there's 13.7 bits of entropy for that. So yeah, that's how you do that. And so oh yeah, point I was going to make this is from Kaspersky, the one on the right. They actually do kind of do a form of the word list check, but then they still get confused about how long it'll take to crack it. So with the diceware thing, I actually do calculate the entropy. And I've cut it off on the right. It has entropy as calculated by like intelligently, and then entropy is calculated stupidly, and it's like 150 for each of those or something like that. So yeah, take a look at the source code if you're a Ruby person. Sure.
In the world of the corporate, how about the gamification aspects? So instead of you having this with the Kaspersky, you each month challenge the users and crack their passwords, and then says the one who has the best corporate world.
Yeah, so my company actually does that to ourselves. As far as I'm aware, we do try to crack our own passwords, and so anyone that not consistently, but it is a thing that has been done. My dad's company as well, they started doing that and started sending people like, hey, this is your password in an email. Please, please change your password. so I absolutely love that idea of if I'm able to crack your password, then an attacker is going to crack your password. So please change your freaking password, and hope that someone else doesn't see that email before you do. Anyway, is there another one?
Yep.
Oh, sure.
Do you have any advice or comments on what to do when you're facing compliance requirements that force password rules on you that might not actually be beneficial for security, and especially how that deals with, I forget the name of the research, but kind of the shape distribution of the passwords? Are you familiar with that at all?
Yeah, so I have actually, there's been once or twice that I've generated a random password that was like 24 characters or something like that in LastPass or something, and I paste it into a website and it says, oh, you've got 3 characters in a row that are the same character. Having a requirement like that actually reduces the problem space, right? So rather than there being 96 to the 24th possible combinations, you're taking away a bunch of combinations that have some dumb rule, like you can't have X number of letters. You must have at least 5 numbers or some shit like that. Like they all reduce security in the process of trying to increase security. So diceware, for example, they're all lowercase, right? There's no uppercase, and you could have like no numbers or symbols in your password. But if you've got 6 diceware words, then no one's going to guess that, right? So I'm not a fan of having those kind of complexity requirements, those kind of rules on what the password might look like, because they're frankly incorrect. Like that, they're not increasing the security.
So how about like syllable dictionaries, so that a user's not putting really common syllables into their passphrase? Just say, well, we're going to block off a lot of English. You got to use something that's got a lot more randomness to it.
Well, blocking off English would also block off the diceware word list, or like our cool I bet if Iltister Statinard. I mean, that is actually a decent password. It's got like 60 bits of entropy or whatever, which for NTLM even it would take a pretty long time to crack. So again, you're putting some kind of complexity requirement on there to be annoying and not to increase security, because it just doesn't. So.
Do you have any comments on the frequency of changing passwords and how it affects entropy, especially given the movement towards not changing passwords on a regular basis?
So basically all the research says don't make people rotate their passwords because the problem is if you tell a user that you're going to have to rotate your password, then they're going to do something crappy unless you basically force and train everyone to, here is your password written down in a sticky note or whatever, and it is a secure random password, memorize it. Then now it's of course written down on a sticky note, but the fact that you have to keep coming up with new ones, I've been able to do it with generating diceware passwords because we have that same corporate requirement of every 90 days change your password, but at least it doesn't help. Because most people don't do what I do and generate, actually random passwords, and it encourages bad password practices. So you should only need to change your password if you suspect that it was leaked, right, or compromised in some way, or written down on a sticky note.
Okay, that has to be the end of the questions, I'm afraid, because the session's now closed. But I'm sure, will you be able to stay around for a little bit afterwards?
Yeah.
If you want to. Thank you very much.